Hello everyone and welcome to my video tutorial on Introduction to Computer Programming using Python Part 1. This is the 11th class of a series, Files and Exceptions. The objective of the class today is to learn about file processing in Python. We will also learn about the JSON data file format in Python. We will learn about errors and exceptions in Python. Motivation. Part of any software is data, which is usually stored, retrieved, and manipulated. Data is usually stored in files in one format or another. Therefore, a thorough understanding of the concepts of files is indispensable to the programmer. JSON is also one of the most generic formats for storing and sharing data between different software in different programming languages, and so should be well understood by any programmer. Also, understanding the concept of errors and exception handling is very important for every programmer in any programming language. Content: Introduction to files in Python, reading from a file, reading a whole text file, reading line by line, making a list of lines from a file, working with the file's contents, writing the whole content to a text file, appending contents to a text file, introduction to exceptions, using exceptions to prevent crashes, handling the file not found error exception, working with multiple files, downloading, storing data, JSON, using JSON.dump and JSON.load, saving and reading user-generated data using JSON. Learning outcomes. At the end of this class, participants should be able to create and open text files for reading, writing, appending, and data manipulation. Create and open JSON files for reading, writing, and data manipulation. Identify and handle general and file exceptions. Introduction to files in Python. What is a file? It is a location in the permanent memory of a computer that contains an organized body of information stored in a certain format. File formats. Different organizations of information such as documents, images, audio, video, presentations, etc. have certain formats of storage. These are things that you are already familiar with if you have been using a computer. So, the files are stored with a name and a specific extension which indicates the type of information that is stored. For example, if you have been using Microsoft Word in your computer, then your Microsoft Word document would usually have a name which you give to it, and it will have an extension which indicates that this is a Microsoft Word document. So the earlier versions is .doc. The extension begins with a dot after the name of a file, then you have the extension. The more recent versions of Microsoft Word is docx, D-O-C-X, extra. If you have been working with PDF documents, Adobe Portable Document format, it has its own format. So this is the format that designates that this document or this item stored in a computer is a type of this item. Then if you have been playing around with photographs, uploading photos into Facebook or Amazon or wherever, they usually have the extension that indicates that it is a photograph type. For example, the JPEG format, which is popularly used, Joint Photographic Expert Group, either JPEG or JPG, they are the same. We have mypic.png, Portable Network Graphic, which is its own format. mypic.gif graphic interchange format. These are various image file formats. Some of them are specific to certain operating systems. For instance, BMP, bitmap. Windows bitmap is specific to Windows. I suppose that Apple have their own. There are so many of them online. You can check them out. We can't put all of them here. So we have video formats. If you have been uploading videos to YouTube, to Facebook, to Instagram, wherever, you normally have a format also. So we have the MP4, we have the AVI, we have WMV, we have MOV for Apple, and so on and so forth. So many of them. We can't put all of them here. So there are different text file formats. For instance, we have the .txt, which is plain text, and then we also have the JSON, which is JavaScript object notation format, which we will learn about today. So why are files important? I don't need to tell you this. If you've been doing any useful stuff online, you will know why files are important already. You've been uploading files, you've been downloading files, so they are important. Saving data into files will make your programs easier for people to use. Imagine a program that does not allow you to save files. You can't upload a file, you can't download a file. That seems to be like an experimental kind of software that is really not serious. If you want to create something serious, it will likely involve uploading and downloading of files. If you created a simple website that just shows information about your company, you may be able to do that without a file. But if you really want to show things like images or pictures, then you have to upload some files there to be displayed on the page. So that's how important files are. Saving data into files will ensure that the user data does not get lost when the program stops running. You can write a program that reads in the contents of a text file and rewrites the file with formatting that allows a browser to display it. Now, plain text files can also contain an enormous amount of data, such as weather, traffic, socioeconomic data, literary works, and a lot more. So it cannot be overemphasized. Reading from a file is particularly useful in data analysis applications, and also to any situation in which you want to analyze or modify information stored in a file. So let's go straight to practical work. We want to start by reading, which is the easier part to do. So let's begin with the simplest of files, which is a simple text file, .txt. So we want to read from a plain text file using the open built-in function of Python. The open function requires the name of the file you want to open and its argument. So I will explain the program. We will call this program FileReader0 to demonstrate basic file reading in Python. Import os.cls. So let's look at two methods we are going to use to open it. The first one is just to enable you to understand that when you want to open a file from a computer, Python needs to know where the file is on the computer, and that is called a directory. So the code begins with open, and you state the directory. I have abbreviated it here, this C // pydigits.txt. So before you can open a file to read it, make sure the file is somewhere, it's existing. So you say open, and then you put the directory, which is the place where the file is on the computer, in the parentheses and in quotes, and then you say as file object. Now the file object you are seeing here is just a variable. It could have been anything. You could have put your name here. With open, the name of the file, as whatever you want to put here. and then a colon follows. Next thing is you now say create a variable. This is a variable, it could have been any name also, equal to file object dot read. So if I put my name here before us and say which open as Ino, I will now say ino.read. So when you say .read, it reads the entire content of the file and puts it inside this variable content. We can now print contents, and it's going to print everything that is in the file. So that is one method of doing it in terms of this directory issue. Now before we continue, if you use the with statement we see here, Python will close the file automatically when this with block, which is just everything indented under the with, closes. The moment the with block finishes execution, it will close the file. Now one thing you should know about file reading is when you open a file to read it, you must make sure you close the file. But Python has made it easy for us so that we don't need to explicitly close the file if we use the with statement. The second method is very practical. The reality is when you are designing a software for people that will pick something from somewhere in their computer and put it on the screen or display it, how do you know exactly which directory everybody, thousands of people or millions of people, are going to keep their file? You don't know. So the first method we used here is very, very impractical. This is not what we should be doing at all. What we should be doing is make Python to get the current directory where your program is executing. So we'll do that. We'll declare a variable and say current directory equal to os.path.dir name, and then you say os.path.realpath file. What this means is the directory where this program is executing, please get it. In any person's computer in the world who is using this software, whatever directory the software is running, get it. That's where the file will be stored. So you can actually print the directory and it will show you everything that we have listed here before. We can now use that directory. We just say with open, we're now trying to use fstring to create a full path here by indicating the file name. The only thing you will tell the users of the software in future is that whatever file you want to open, make sure you keep it in a specific directory where the program code is executing from. So you say as file object. So we have our current directory here, and then we append this slash, and then we put the name of the file to complete the statement as file object, whatever variable you want to call it. The rest of the program is the same. So we say create a new variable and say contents2 equal to file object.read print contents2. Now if you run this program, this is what the output looks like. So you can see the full directory of where the file was actually stored. It was printed out, and this is the content of the file. So we are now going to go to Visual Studio Code and run this program and see how it really works. Alright, so before we go to Visual Studio Code, this is the directory where the file is, and the file we are trying to read is pydigits.txt. I will double click on this file now so we can see the content of the file, what is actually written there. It's the first few digits of pi that is inside this file, as you can see from here, 3.14159, and in the second line will continue, and in the third line will continue. You can download this file somewhere from the internet. If you type pydigits.txt in Google Chrome, or you can make the file by yourself by copying the item you see here and putting it in a file and saving it. Just open Notepad. If you say Notepad on this side, just begin typing, and then you say file, save as, you give it a name, PyDigits. Just type PyDigits. Make sure you know the directory where you are saving it, where your current program is running from. If you come here, you see the directory where it's running from. This is all the Python codes that we are going to run in the class of today, and this file is saved in exactly the same directory where the program is running from. Let me show the program here now. File reader 0. This is file reader 0. Now, when you use this current directory os.path, it is actually going to get this particular directory where the program file reader 0 is running from. So from here, you can decide to use the path directory, or you could have even created a folder called text files and put it inside here. In that case, when you want to call the PyDigits, you would first of all call the text files folder before you call the PyDigits text files. So if we had put the PyDigits.txt in a folder in the current directory where the program is running from, this is what we would have done. But since we put the PyDigits.txt file directly in the directory where our program is running from, we call it exactly like this. So this is the best way to open the file, such that if any person downloaded your software anywhere in the world, no matter which computer, no matter which directory they have, it doesn't have to be the same. It uses that directory to go and look for where the file is, and everything works perfectly. This is what happens in real world software development, not what is on top here. This is not what happens. What you have here is what really happens. Okay, so now we know that the file is there and that's the content of a file. We will now try to run this program. Since we don't need to enter input, we can use ARAPL. Now note that it's not every time that ARAPL shows on your screen. You know, the last time I was trying to run it wasn't showing. So that's why I put the keyboard shortcut here, so that in case your ARAPL is not showing here, you can just use Ctrl plus Shift plus A. Then you modify something. Now what do we have? You see? So two parts of the programs of the program are running. I am going to now comment one part of it so we can see exactly how each part of the code runs. If we comment the bottom part, the first part is what is running. So we use with open, go to the full directory, which looks like manual labor, and then we read the contents of the file and print it. What you are seeing here now is the print output. So if we remove the comment from the second part, what you see here is when we printed the directory, see that this is the directory that I showed you where the program is running from. You see? So from there on, you can search for the file. You can put the file in as many folders as you want and just list all of them here. So you will tell the users of the software that your text files should be kept in so and so folder and should be named with so and so name. Right, so in the previous session we saw how to read a whole file, but sometimes you want to read a file line by line. So this example shows us how to do that. We'll call it file reader 1. From now on, we are going to be using the os.path to get the current directory. So we assign a file name. We can call it file name equal to F. We are using F string here, as you must remember. Current directory PyDigits. We have appended the file name with open file name as file object, or whatever variable you want to call it. But this time around we say for line in file object print line.rstrip. So we are reading line by line, and what we are just doing is printing. Now if you run this program, this is what you get. So here we are in Visual Studio Code. We are going to open ARPL again and try to make some updates. So suppose we want to make a list of lines from a file. To make a list of lines from a file, we use the readLines built-in function of Python. So we are going to call this file reader2. As usual, we get the current directory, we assign a file name, and then we open. So we make a list. We can now say lines equal to file object dot read lines. Take note of the read lines. Instead of the read, we are using read lines. So we've created a list. We can now print the content of the list. For line in lines, print line.rstrip. Now there are two print statements here you should notice. The first one, which is this one, is like the previous example we saw. It's using a for loop to print line by line. The second one is just going to print the entire list as a list because we actually created a list. So if you look at the output of a program, there are two prints here. This is the first one that uses the for loop to print. This is the second print that actually prints the whole list. Here we are in Visual Studio Code. We can update and we see the output. Now if we comment the last print or the second print, so we can see the output one by one. We see the first print is for the for. This output you see here is for the for loop, which prints the content of the list one by one. To show that we actually created a list with this code you are seeing here from the read line, print directory. Print directly, and what do we see? We see a whole full list that is printed. So you see this /n just indicates that it is a new line in the file. That is, after this, the next one continues in a new line, and after this again, the last one continues in a new line. That's why we have them first line, second line, and third line. So how do we work with the file's content? We see an example. We'll call this file reader3.py. As usual, get a directory, assign a file name. This time around, we are going to read a file that is called pymilliondigits.txt, which I also downloaded from the internet. Just Google this information and you will be able to get a text file from somewhere. So the file is so large, we will open it as an object, and then we will read it line by line. So because it may be difficult for us to print the million digits, it's going to take some time. Let's create an empty string variable. We are going to call it pystring, and then we say for line in lines, pystring plus equal to write strip. You know what this is, as usual. So we are adding items to pystring, creating one full string from all the lines that we read. So we can print just the first 52 items in the list because there is quite a lot and it might take some time. That's what this print is doing. We can also print the length of pystring to see how long it actually is. Then we can actually do something with it. We want to check whether your birthday is contained in pi. So we tell the user to enter the date of birth in the format of month, day, and year. And then we will say if birthday in pystring, print a message. Your birthday appears in the first million digits of pi. Otherwise, print your birthday does not appear in the first million digits of pi. So when we run the program, this is what it looks like. What you see on this side, on the right side, on the top print output is the first 52 digits of pi. And then the program prints a message that says enter your birthday in the form of mmddyy. And if you enter your birthday, look at the output below. Now, as we already know, when you are running a program and it requires you to enter an input from the keyboard, ARPL does not handle it. So you have to look at terminal window to actually handle that, and that's where the output goes. So a birthday is entered there, and it actually appears in the first million digits of pi. So this program is pretty long because there are two parts of it. We are going to use docstring comments to remove the side that requires you to enter an input by hand from the keyboard. So we have it like this. For the first part where you don't have to enter any input, you can use the arrow APL to show the output. But before I run this program, we will go and look at pi million digits.txt and see what the file really looks like. If I double click on the file, the first 1 million digits of pi. I'm going to close this now. So if we use arrow APL for this one, because we don't need to enter an input on this part, we can just see the output. That is the first 52 digits of pi. So let's close the arrow APL and uncomment this part so we can run from the console terminal. In this time, you are going to click run. So it says enter your birthday in the form of MMDDYY. Your birthday appears in the first million digits of pi. Can we enter something random? Just any random number that may give us a negative output. 010101. What happens? Your birthday does not appear in the first million digits of pi. Alright, so we have been reading files, which is the easier part to do. Now let's see writing to a file or creating a file. So we start with writing a whole content to a text file. We call this file writer0.py to demonstrate basic writing content to a text file in Python. As usual, if you want to write a file somewhere, you have to specify the directory where the file is going to be. So we say get current directory the way it will be done professionally. From that current directory, you can create a folder where you want the file to be, and you must give the file a name. So we say file name is equal to use fstring to create, use current directory, and we'll call this file name programming.txt. That's the name we give to it. It's a variable. If you want it to be in a separate folder, you must put the folder name after this current directory before you put programming.txt. If the folder did not exist, Python will automatically create it for you. So if this file programming.txt did not exist, Python will automatically create it for you and put the content you want to put inside. So this time around we say with open. Take note of what we put inside here. With open, there was an additional argument. This W means we are opening the file to write. W for write. So we say as file object, which can be any variable as usual. So we now write some content. File object.write I love programming. You can add more content. This /n, you know what it means. We are going to the next line to write. File object.write I love creating new games. Then we'll go to the next line again. File object.write I love creating algorithms. Then we'll go to the next line again. File object.write I love flowcharts. If you go and open the file from the directory where you wanted it to be stored, it's going to show you the content of a file like this. I love programming. I love creating new games. I love creating algorithms. I love flowcharts. So here we are in FileWriter0. I am now going to open the directory and we find out that programming.txt is already there because I created it before. This is the content of programming.txt at the moment, so I am going to delete it. We will run this program and keep this folder open so that you can see when Python automatically creates the file and puts it in the directory. So we don't need to display anything in the RPL now because we are not printing anything. So I'm going to click run. Keep your eye on this right part, this list of text documents. Keep your eyes here, and you will see that programming.txt will be automatically created. So we'll click run. Alright, so programming.txt has been created. If you double click and open the file, you see everything we wrote. I love programming, I love creating new games, I love creating algorithms, I love flowcharts. We can close the file. Suppose you are collecting data and you want to be updating the file regularly, and the file is getting larger and larger. You want all the data to be there. It means that you should be appending data to the file. How do you do that? Not always recreating the file every time. So we'll call this file writer 1 to demonstrate appending content to a text file in Python. In this case, when you open the file, you are going to use the A word. A means we want to append data to the file. Recall that W means we want to write data to the file. Recall that when there is nothing in the parentheses apart from file name, we want to read the file. So we say write some additional content to the file. Take note, when you are creating a file to append, the file must be there in the directory, otherwise you will get an error. The /n/n you see here is to create 2 new lines before writing anything else in the file. So we say appending file, go to the next line, file object.write. I also love finding meaning in large data sets. File object.write. I love creating apps that can run in a browser. Next line. Now when you open the file after you run the program, you will see that this previous file we created, some information has been appended in the file below. So this is file writer 1, which I was just explaining. Now I'm going to open the directory so we can see programming.txt is there already. If you want to append the file, you must make sure that the file exists before you append. Now let's open the file so we can see the current content of the file. Close it before you run the program. We'll run the program again. After that, open the file. So you will see that new content has been appended to the file. Introduction to exceptions. Whenever an error occurs in a Python program, which you will see frequently if you are learning programming, or even if you are a professional programmer, Python does raise an exception object. So what is an exception object? They help to manage errors that arise during a program's execution. If you write a code that handles the exception, then the program will continue running smoothly. If you don't handle the exception, the program will halt and show something called a traceback. Traceback includes a report of the exception that was raised. In Python, exceptions are handled with the try except block. So we see an example. Exception 0.py to demonstrate exceptions in Python. If you encounter a divide by zero situation, you get an error, and that error can stall your program. Recall when we were trying to solve the quadratic equation problem, and we had to make sure that parameter A is never 0, because A is being used to divide some other parameters somewhere in the code. So what happens when you encounter something like this? A user might inadvertently type 0 or even deliberately type 0 to crash the program. A virus could do that, a faulty sensor could do that, so on and so forth. So you should be able to handle such exceptions in Python. How do we do that? We use the try except block. So we say, instead of just saying 3 divided by 0 directly, we can say try print 3 divided by 0, but when you encounter an exception, a 0 division error exception, you can print a message and say you can't divide by 0. The second part of the code will not crash the program. The first part of the code will crash the program. So here we are in Visual Studio Code. First thing I'm going to do is uncomment the 3 divided by 0 and comment the other part of the code that handles the exception. So we can see exactly what happens when you encounter this kind of situation in programming. We are going to open ARAPL and just modify. See, this red block comes here and shows you that there is an error. See, the traceback shows here divide 0 division error has been encountered in the program. So the program crashed and it doesn't go anywhere from there. Now if we comment out this bad code and we use the exception handling code on this side, you can see the output that we have in the array here. You can't divide by 0. The program did not crash. You did not see any red block on this side, meaning that the program is still running. If it was the kind of program that accepts user data, it's going to keep accepting user data without crashing the program. If the user keeps putting information that is erroneous, like giving a 0, it will keep running until the user gives something else. That is a better way of programming, using exception handling. So let's see practically how to use exception handling to prevent crashes. We call this exception 1. We are still demonstrating exceptions in Python. Print a message. Give me 2 numbers and I'll divide them. Enter Q to quit. While true, first number equal to impute first number. If first number equal to Q, break. Otherwise, request for second number. Impute second number. If second number equal to Q, break. Otherwise, create a try except block. Try. Answer equal to int first number over int second number. Except 0 division error. In case you encounter 0 division error, just print a message you can't divide by 0. Otherwise, print the answer. So we can't see this program in ARAPL because it requires you to enter an input from the keyboard. So here we are in Visual Studio Code and we are going to run this program now. Enter first number, so I say 8. Enter second number, I say 0. You can't divide by 0. Can you see that the program did not crash? It actually came back to ask for the first number. Enter first number 8, enter second number 2. Result is 4.0. If you want to quit, just press Q and you're out of the code. So let's learn how to handle the file not found error exception. We call this exception 2. Let me explain this further. Like I said before you append a file, you must make sure that the file is in the directory, otherwise you'll get an error. Before you read the file, you must make sure the file is in the directory, otherwise you get an error. The only condition under which you will run the program is when you want to create a file, right? If the file is not there, it will be automatically created. Otherwise, for the other 2 situations, reading and appending, you get an error. So what do? We also use exceptions to handle such kind of error so that the program does not crash. So let's get the current directory. Let's get a file name or create a file name, alice.txt. Then open the file with the file name, which open file name This time around we are adding a coding and encoding to the file name. Then we can call it as f, any variable, whatever you want to call it. F is just a variable. So we say contents equal to f.read. Take note, we put it in a try here, not the way we have been doing it before. We catch the exception. Except file not found error. Print sorry, the file does not exist. So this is a better way of writing a program. Now, all the kind of exception errors that are available in Python are numerous. If you go to Google and type Python exception errors, you will see the whole list of the kind of errors that you'll be able to handle in a program. So here we are in Visual Studio Code, the program we just described in the presentation. First thing we are going to do is look at the file alice.txt, whether it does exist. So this is alice.txt, which I actually downloaded somewhere from the internet, and I will show you where to download it from. So if we run this program now, we may not be able to demonstrate the error unless we do something. I want us to see a situation where alice.txt does not really exist in the folder. So how do we do that? I'm going to rename this file and call it alice.txt. It's not the same thing as alice.txt. So alice.txt is really not in the directory. And what happens when we run the program? It says, okay, it's still running. Let's wait for it. Sorry, the file does not exist. It actually gave you the whole directory list of the file before it comes to say alice.txt does not exist. So the program actually failed gracefully. Okay, so if we go back and change the name of the file to Alice, and run the program again, this time around it's not going to fail. Okay, so the program actually ran. So is it possible for us to work with multiple files in Python? Of course we can. We call this file reader 4 to demonstrate working with multiple files and failing silently in Python. So we are going to create a function. This function is going to read a file and count the number of words inside the file. So we call it count words. We just put a file name inside it. Then we get the current directory where the program is running at the moment. And then we see full file name is equal to, we use the file name that we put here to create a full directory listing of where the file is. Now we are going to use a try except block to count the approximate number of words in a file. So we say try with open, just like in the previous program, contents.read. And then we say except file not found error, print sorry, the file name does not exist. Now if you want the exception to pass without printing any message, you will uncomment this pass and you will comment the print that we have here. We'll see that in the demonstration. The program continues. Otherwise, again, we can now count the words. Words equal to contents.split, and then you say num words, which is number of words, equal to len words. So when we use contents.split, we are splitting every word in the file using the space that exists between all the words. Remember, we read the whole file, so we split it and we can count how many words are in the file and we can print it. The file has about num words. The function we just created, let's use it to do something. So we'll put multiple files in a list: alice.txt, siddhartha.txt, mobydick.txt, littlewomen.txt. All these are textbooks. Then we'll put them in a for loop and use the function which we created, count words, to count the words in each of these books. How many words are there? So where did we get the files from? If you go to gutenberg.org, you are going to see all the files that we are using here. When you run the program, you will see that the file alice.txt has about 29,594 words. The file siddhartha.txt has about 42,201 words. The file mobydick.txt has about 215,711 words. Sorry, the file Little Women does not exist. If we come to the directory, we see that alice.txt, I have downloaded it. mobydick.txt, I have downloaded it. siddhartha.txt, I have downloaded it. The only one that did not download was Little Women. So, where did I get the files from? If you go to Google and you type gutenberg.org, free ebooks. So you can search for ebooks, Alice in Wonderland, and you click on Alice. Now what we want to download is a plain text UTF-8. You can click on this to download, and it's going to download to your computer. So what you just do is save as, and you call it Alice. So when you want to save it, if you are not familiar with saving of files, make sure you save it in the directory where you can look for it. In this case, I saved it in codes. See, I already have Alice, so I don't need to save it again. You don't need to type the .txt here. It's already indicated in the file type as text document, so you will just click save. So I don't need to do that. That's where the files came from. So we can close Google and try to run the program. Since this program does not require you to type an input from the keyboard, we can just use ARAPL to show it running. So take note, the only file we did not have is Little Women. When you are running the program, you can play around with it. You can delete or change Moby Dick, or we even do that later. So let's run it. The file alice.txt has about these words. The file siddhartha.txt has about these words. The file mobydick.txt has about these words. Very good. Same output you will see in ARAPL. Now we are going to do something here to show. If we change Alice again like we did before, rename it to Alice 0, press enter, and run the program again, what do I have? Sorry, the file Alice does not exist. The file Siddhartha has, the file Moby Dick has. Sorry, the file Little Women does not exist. So, storing data in JSON. JSON is very popular and is called the JavaScript object notation. Apart from text files, data can be stored in a more advanced structure such as a JSON file. JSON data format is not specific to Python. It enables you to share data among many other programming languages. Let me explain it this way. There are some programming jobs you do that you cannot use Python alone to do the job. Sometimes your Python program might be producing data that is being used by another person's Java program. If you have done some programming in robotics, you will discover that for one problem you write some parts of it in C, some parts of it in C++, some parts of it in Java, some parts of it in Python at different levels, and all the codes are running together and exchanging data at one time or the other. One of the best formats to exchange data in that way is by using JSON. That's why it's important for us to learn about it. So it is a useful and portable format and also easy to learn. We'll go straight to an example using json.dump and json.load. So we'll call this json test0.py to demonstrate basic JSON using dump and load in Python. We have to import JSON in order to be able to use it. It's already in Python. So as usual, we get the current directory. We create a file name and call it numbers.json. We make a data list. Say numbers equal to 2, 3, 4, 5, 7, 11, 13, and we open the file for writing. Take note that when we open the file for writing, we are creating a file. If the file numbers.json was there already before, it is going to recreate it and replace it. If the file does not exist before, it's going to create it afresh. That's what the W is for. So, to put data inside the new JSON file we created, we just say json.dump numbers, dump the data into the file. And we can also open the file for reading. After the with block has finished execution, the first one, it closes the JSON file. So you can open it again using another with block. This time around, you just say file name as G, whatever you want to call it. And then you read. In JSON, we use the load to read the data. We use the dump to put the data in the file. After you read, you can print the data. Now when you run the program and you print, this is what comes out from the output. So here is JSON test 0. First thing we are going to do is check whether the numbers.json file exists already, and we are going to delete it, so that when we run the program, we will see that the program actually creates the JSON file automatically into the directory that we specified. So we minimize this window so we can see everything the way it runs. Now we run the program. So you see, numbers.json has automatically appeared, and when you double click this file to open it, it shows you that a list has been written into the JSON file. So we'll close it. You can open it using Notepad. If you don't mind, open with Notepad. It's the same thing, shows you. So let's look at saving and reading user generated data using JSON, the way it will happen in real life. We'll call this JSON test 1. As usual, we'll follow the protocols. So we'll create a function, get stored username, assign a file name, current directory username.json, try, get the stored username is if available. So we have a try block. We say with open file name as f, username equal to json.load. So we are using this try except block so that if the file does not exist, we can be able to catch the error, file not found error. If the file exists, when you read, you load the file and say username equal to json.loadf. Otherwise, if the file does not exist, you return nothing. That is return none. Otherwise, you return the username. The first try block will try to execute. If there is an exception, it will come here. If there is no exception, it will go to the else and it will return the username. We continue. Create a new function called getNewUsername. Assign a file name username. Prompt for a new username. Username equal to impute what is your name. With open file name as f. Take note, we did not put this in a try block. The reason is because we want to create a file. So whether the file was there or it was not there, it will create it anyway. So no need to put it in the try block. So we say json.dump username, return username. The program continues. We now want to use the functions we created. So we'll create another function. I will say greet user. Def greet user, we say username equal to get stored username. That is the first function we created. If there is actually a username that was returned, then print welcome back username. Otherwise, there was no username that was returned, then call the second function that tells the user to enter a name, and the name is stored in a file. Print we will remember you when you come back, and end. So we now call this function that we created that actually uses the other two functions. We just say greet user. So here we are in JSON test 1. Since we are dealing with this file username, I have already put some data there before in the previous test that I did. So if we open this username, you discover that there is already some information there. I am going to delete this file now. So we'll recreate the file afresh so that everything is brand new. So I will run the program. It means the file does not exist. You know how it's going to happen. This part of the code where we try to open and the file does not exist, file not found, it returns none. So the program as it is now is going to ask for a username because the file does not exist, in which case it is the get new username that is going to be executed here. We will run the program twice. What is your name? I say Ino, and press enter. We will remember you when you come back, Ino. Now let's go and check the directory. You discover that the username.json has been created, and the only thing that is inside it is Ino. Now if we run this program again, it's going to say welcome back, Ino, and that's exactly what the program is doing. So if you have already created a JSON file, can you be able to append data to the file also? Of course, it's possible. We are going to call this JSON test2 to demonstrate appending data to a JSON file in Python. We follow every other protocol, and then we have the file name username.json. Now take note that when you want to append data, you must make sure that the file already exists before you can append data. So we create a new data list that we want to append to the file. We say numbers equal to 2, 3, 5, 7, 11, 13. We open the file for reading. See, we cannot append the JSON file directly the way we append an ordinary file. Rather, what we are going to do is we will open the file and read the content. After we finish reading the content, we will now append something to what we read, and then we recreate the file by writing everything back to a new file with the same name, which will overwrite the previous file. Maybe there are other ways of doing that which you can search online, but this way does certainly work. So we say rd numbers equal to json.loadg. Print rd numbers. We have already loaded the whole data in the JSON file into rd numbers. Then we append the list to the data read from the file. We now say lrd numbers, which is a new variable, equal to, we use an f string to do the appending here, rd numbers, and then numbers, we put them together. We can print it and see what it looks like. Then we can use the name of the same file to write a new file. So when we say with open file name w as f, whether the file exists before or it does not exist before, it doesn't matter. We are going to recreate the file and overwrite the previous one. And then we say json.dump lrd numbers f. Dump the data into the file. Now when you open the file, it's going to be like this. The previous Ino was there, and then a list has been appended to the file. So here we are in JSON test 2 to demonstrate appending data to a JSON file in Python. Before we run this program, we are going to open the username and see what is in the file at the moment. We only have Ino, and we make sure that the file does exist in the directory. So we run the program. Data is printed out. Let's confirm that the file has already been updated. Of course, you can see that the file has been updated. So we have come to the end of the class today. Our bibliography still remains the book of Eric Mathis. Please like, share, comment and subscribe for more videos. Thank you very much and see you in the next class, which is going to be the last class of the series.